Number 22 says divide. And when we're dividing by a monomial, 3ab, we actually are distributing that denominator to each and every term in the numerator. 12a cubed b over 3ab minus 9a squared b squared over 3ab plus 6ab over 3ab. Simplifying each one individually, this is 4a squared, and the b's divide out completely, minus 9 divided by 3 is 3, a squared over a is a single a, b squared over b is a single b, plus, here the a and the b divide out completely, and 6 over 3 is 2, and that's complete now. All right, here are some exercises from Chapter 5. Factoring. Let's look at number 23. We have two terms and we must consider the greatest common factor and factor it out. Between 6 and 12 we can take out as much as 6. Between a squared and a we take out a, and between b and b squared we factor out or extract just a single b. And when we extract 6 and an a and a b from the first term, we're left with a single a. And then minus, and extracting a 6 from 12, we're left with 2. A is completely factored out. B from b squared leaves a single b. And we're done. One step. Number 24 is very similar, but because the lead term is negative, that means we must factor out the negative along with any common factor. In this case, between 12 and 20, it's 4. And between x to the fifth and x cubed, we can extract as much as x cubed. If we factor a negative 4 away from 12, we're left with 3. And factoring x cubed from x to the fifth, we're left with x squared. Factoring a negative 4 from 20 leaves us with a negative 5. And that completes this factoring. We should look to see if this binomial is factorable to see if we can factor it completely, but it isn't. It's not the difference of squares because of the 3 and the 5. Those are not perfect squares. Okay, in number 25 we have 4 terms, and this requires us to look at factor by grouping. That means 2ab squared minus 4b squared are grouped together, plus sign's important, 5a minus 10 are grouped together. Out of the first grouping, we can factor 2 and b squared. And we are left with a minus 2. Still plus. And out of the second grouping, we can factor 5. And again, we get a minus 2 as the binomial factor. Now we're going to factor out the a minus 2. And when we do, we are left with, in another grouping, 2b squared plus 5. And that's completely factored. By the way, let me put a box around this first. But let me also mention that we can check our work. And the way we check our work is to simply multiply these back together. I'll do it very quickly here. 2b squared times a is 2 and an a and a b squared, minus 4b squared plus 5a and minus 10. And when we compare that to the original, they match up exactly. Checking is not required. It's just a very good idea. And you might want to use scratch paper for your checking, so it's not actually a part of your written test. Either way is fine. Number 26 also has 4 terms, and we will again use factor by grouping. One thing we must be careful about is this minus sign right here. We're going to make that plus a negative 6x. And that's because we want a plus sign between our two groupings. So 15x cubed minus 20x squared plus, and overemphasizing the plus sign, I know, negative 6x plus 8. Out of the first grouping, we can factor 5 and x squared. And when we extract that, we got a 3x and a minus 4. Plus, here we factor out a negative 2. And again, we're left with 3x minus 4. So the common factor of 3x minus 4 now is extracted, and that leaves us with 5x squared plus a negative 2 is the same thing as minus 2. As before, it's a good idea to multiply that back together to check the work. Okay, here we have a trinomial, and this is from section 5.4. And what we've learned is that we must consider the factor game. And that means the key number is 5 times negative 8, which is negative 40. And we must find two factors of negative 40 that add up to the sum number of negative 6. That's going to be a negative 10 and a positive 4. Now this is a multi-step factoring, and we take the negative 6x, remember, and split it up into the values that we found here. Not exactly negative 10 and 4, but instead negative 10x and positive 4x. The 5x squared is still there, and the minus 8 is still there. And I see a plus sign between two groupings, so let me group the first two and group the last two separately. This is now 5x can be extracted or factored out, leaving us with x minus 2. And from the second grouping, we can factor out 4, again leaving us the quantity x minus 2. Now we can factor out the x minus 2, and we have left over 5x plus 4. And again, we can check our answer using FOIL or whatever other technique you want to use, but we do indeed have the correct factoring.